So, first of all, thanks for coming. Thanks for having me. I hope this is going to be an exciting moment for those who haven't heard about Lexon. Who here has heard about Lexon? Okay, cool. Quite somebody. So, I would like us to use the occasion and just have a very direct conversation, a dialogue even. If you have any questions, just please show up and ask it, if that's possible with the microphones. And I'll just say, if we address them later, then we'll address them later in the talk. I'll go through pretty much all that is there. It's a rich salad of things. And I hope that no matter how technical you are, no matter how high level this might be interesting for you, I'm ready to go deeper into any direction that might be interesting for anyone in the audience. So first, some words about me. I'm Henning. I have started programming at the age of 12, so sometimes I think my brain got wired a little bit according to how stacks work and how binary works. When the whole blockchain started, the whole blockchain stuff really started, I should say, when Ethereum came to Berlin, that is, I was actually working at IBM, and that's how I ended up also being the first architect of IBM's very own blockchain. After they concluded Ethereum was too much of a mess, they wanted to try their own thing. I was the first architect of Hyperledger. I actually met Janislav in Hong Kong on a crypto conference when he was traveling the world. And even back then, he showed me the conversation that's still on the internet there somewhere that he had with Vitalik that could be termed the start of the idea of Ethereum. So back then, it was a crypto conference that was very much still focused on Bitcoin, and Ethereum was very young. And now we're here, and I have followed the development of Æternity from the very start. And I'm proud to say that I also encouraged Janislav very much on going for Erlang, going for a technology that I have worked with at IBM, also at other companies, that is very much known for how super reliable it is. And I'm stoked to see that what has been created for Æternity is also going to be a valuable addition to blockchains, especially if you really want to do something hardcore, something real. And I hope that Lexon can be my contribution, also especially for Æternity, to make it more accessible, to deliver also on the motto of blockchain for the masses, because Lexon is all about accessibility, and that is in the end where it all came from. My experience, my long experience in computing, all the things that can go wrong when you code, even among specialists, not to talk even about what the very hard work is as a programmer to try to understand what you should even program. All of this really went into creating Lexon. So this is it. This is Lexon code. This is my favorite example since years now, because it's something very typical blockchain. It's a very simple program that is delivering a value that I think people outside the blockchain bubble still haven't really understood how valuable it is. And the point here is, and that's really the inspiration for Lexon, in doubt, you could put this in front of a judge. Because that's where it started out. As I said, I worked at IBM at the time, and IBM had a very fascinating, a very, very forward-looking concept for creating what they call the democracy of things. And that would be a lot of IoT devices communicating with each other, millions of them. And at some point, of course, you have to ask the question, what happens if something goes wrong? Or maybe even worse, what happens if somebody pretends something went wrong that didn't even happen? And I think a very interesting point for me was when I was at a conference in Florida, where there's a very famous law university, and they had judges on the panel. And the judges laughed at the idea that they would ever look at a smart contract. It didn't really matter to them what you call it. They literally said, I mean, they would pull every trick in the book to not look at a smart contract. They would just try to avoid, and in the end they would call in the experts, but there's no way they would look at the thing itself. So we had this thing, this discussion in the community. Wouldn't it be nice if that could change? Because smart contracts essentially do the magic of transferring possession. But if that is something that can be voided by the law, or judges are not even going to accept that this smart contract is a thing, and in different jurisdictions that is true to a different degree, then you forever stay vulnerable by, let's say, at least the big discussion of whether law is trumping code, or code is law, or the intention of what the code should have been is the new law, or whatever, right? So the idea was, couldn't we make smart contracts readable? And this is, after a couple years, what the syntax is that basically allows you to write code in a way that is as readable as I think is possible. I'm pretty proud of this because it went further than I thought. If you go back and look at the white paper from 2017, which you can check out at lexon.org, you will see that the original syntax was actually more modest. I thought you'd at least have to explain what a colon means. But it turns out that you can go pretty far and create a compiler that can actually be fed with something that at least look, and that's what it's all about, this language, looks very readable and very much like English in this case. We also have a project now going where we're going to try to test a Hungarian version of Lexon, which means like we try to create a Lexon grammar that is basically going to read Hungarian. We tried it with Japanese, we also tried it with German. It seems to work. And I will also show you the compiler and what it actually does, and the grammar and what it actually does, and how it can be translated. And I'm also going to show you a little bit of how it can be translated to Sophia, because throughout the years, we've always also targeted Sophia, targeted Æternity, and we've now come to a point with the 0.3 compiler where we're back at the point with the 0.2 compiler, like it almost just works. There's a lot of time going, of course, into the fine last 10%, so to say, as it always is. I'm very confident that we're very close in producing pretty large code for Æternity. But I'm going to show you what exists there at this point for JavaScript, which is another chapter I'll come to. I would also like to talk to you about the project that I'm mostly involved with at this point. That's the Lexon Hub. We're basically creating something like GitHub. We all know SourceForge. And as a programmer, you might also know that trying to work with non-programmers with online repositories is something that just doesn't work. Traditionally, I think Git itself is just a mess. It's a genius mess, but still, it's just something that grew and became something super powerful and something that you find everywhere now. But source version control is something that we're trying to bring to normal people, and this is very much what the project is all about. But of course, it's also going to be the place where, simply as with Æternity Studio, for example, you will be able to deploy smart contracts and then also manage them throughout their lifetime. And in this case, legally enforceable smart contracts written in Lexon. So very generally, and I also have some practical examples, what is Lexon? Well, Lexon basically is the idea of a middle ground between machines and humans. And it's not something that at the West Coast a lot of people might think is needed, because with a lot of enthusiasm, some people feel that we are very close in computers reading just any text. Understanding a little bit about language and computers, I would say, especially with something that has to be as 100% right as contracts, where you don't really can't really work with a margin of error, that might still be some way off. And the idea of Lexon is to basically have both sides approaching each other for taking natural grammar as it is, but reducing it to a core that still works, but is unambiguous and can be parsed by a computer. That's technically the idea behind. Now, philosophically, that opens a box of a Pandora's box, or something that is almost a trauma, because as it happens, philosophers also, since 100 or 200 years or longer, are looking for a language that's unambiguous, to think better. And for a while, the idea was to create an entirely new language. And then for a while, for 100 years actually, for the last 100 years almost, the idea was, let's try to just pin down what a word means. Let's just have exact definitions. And interestingly, this whole discussion in the philosophical space, of course, informed the research of AI. And what has been called analytical philosophy has basically, without people really realizing maybe, seeped into the mainstream and has dominated our thinking about language for a pretty long time. And that is very word-centered. And interestingly, Lexon is not. Lexon allows you to use natural language and basically articulate logic. But as you know, if you think about a programming language, the names of your variables are actually completely don't matter. The compiler actually throws them away. And that's also what Lexon is doing. And that's very surprising for analytical philosophy, that you end up having meaning being articulated by the web that exists between the words, the variables, and that can be very complex stuff. Actually, much more complex stuff in programming than the examples that Kant or Hume or philosophers in the past thought about, which is a quandary that hit home really badly on AI research, on the traditional AI research, general artificial intelligence research, when basically they were caught out in going about examples that are just too simple, that will not scale. Because as soon as you try to have an example that's just a couple of lines, then being extrapolated to the entire world as the context of the general intelligence that you want to create, you just have a problem. It's just not gonna work. It's just gonna slow down quadratically, and then at a certain point, just not work. And that was a very painful insight that happened now decades ago, but that really kind of cut general artificial intelligence research off its funding at that point. What Lexon does is, in a certain sense, unexpected. And in a certain sense, Lexon might address where artificial intelligence, general artificial intelligence research got stuck. The definition of artificial intelligence has changed a lot throughout the latest decades, and part of it is funding, right? University professors need funding for the research, startups need funding for the research, and so what really means artificial intelligence at this point is not really clear, or has been dumbed down, you could say, or you could say the founding fathers of AI probably would have called statistics what is now labeled artificial intelligence. And Lexon kind of goes back in a different way, and you could say almost that where the general AI research got stuck, which is the intractability of language, Lexon kind of takes first as a problem to solve. And Lexon kind of doesn't solve it even. It just gives you the tools as a user to articulate exactly what you want. And so I wouldn't even say that Lexon is a domain-specific language, because even though it is very focused on blockchain, that's where it comes from, and that's also something where I try to stay and be focused so I don't die from feature creep. But it has turned out that you can use this principle for any type of programming, and it might go beyond that even. You might use it at some point as a better way to communicate within a company, or write specifications, or write laws, better laws. So it can work on-chain, it can work off-chain, it can even work off-machine, because the principle itself is merely that Lexon is matching or is defining the intersection between natural language grammar and higher logic. And unsurprisingly, because you can talk about higher logic in normal languages, you can also find a way to reduce the grammar, so you can basically talk only about this. But it has to be higher order logic. What's not sufficient is a lot of approaches that are out there that basically focus on first order logic. And maybe a valid way to define the difference there is that higher order logic has a bit of reflection, basically. It can look back at itself. It can talk about its own functions. Where first order logic is very reduced to something that can be expressed with subject and predicate, and starts with the typical examples of Socrates as a Greek, and then what follows from that. But programming is higher order logic. It's applied higher order logic, and we now have millions of people who have experience with that. And Lexon is kind of unearthing the link between natural language and higher order logic, which usually we articulate in the formulaic ways of third generation programming languages. So the superficial dream of what Lexon does is very old. Even in the 50s, people started to try to have programming languages that look a little bit more like English. And even the compiler, even the language that the compiler for the first COBOL compiler was written in already had this kind of better syntax, where you didn't only write octal numbers, but you could use English terms for it. And even back then, it was a big fight to even get this accepted, funded, because even back then, just replacing octal numbers with parsable English words looked like not useful. Why would you even do this? Computers don't speak English. Everybody knows this. And this is what, funnily, Grace Hopper talked about their experiment from the 50s, actually, for the first time teaching computers English. But in a certain sense, in a certain different sense, Lexon also brings something full circle that stands at the very beginning of programming. And that is that Leibniz, basically in 1666, in a thesis that's regarded as the first work in computer sciences, for the first time proposed something like programming. And the idea was very new then, because what they had at that point were brass machines, brass calculating machines, and they could be programmed, couldn't be programmed, they could just be told numbers basically in wheels, and then they would give you a result, right? So the idea of having wouldn't it be great if we could have some way of dynamically telling those brass machines a different formula, or just a more interesting formula? That was the actual new thing there. But Leibniz also, from the very start, had the idea that you could program other things than just math. And his very first example in this very first work of computer sciences, as an example for what should be programmed, was actually a law. And arguably, logic was just not up to the task of really helping the legal profession for centuries, for millennia. And today we have a situation that famously logic isn't even taught if you study to become a judge or a lawyer or attorney, because it's considered so far away, it's so unuseful for deciding real cases, for something in the, doing something in the real world of law. But that we now have something, we talk about smart contracts, we talk about computational law, and we talk about being able to put a program in front of a judge, this is actually not a surprising combination. It's actually very much where it started. And at least it's very obvious for lawyers how much logic is in the legal system. And that's especially true also for the German legal system that was created with a hierarchy in mind and with a certain ideal of a logical built in it. So Lexon solves something for computational law that has been looked for a long time. And that is one very interesting aspect that it has for sure. It's basically adding the second part where something like a speed up, like what happened in the 70s, when all of a sudden you could look electronically, you could search electronically what you had in a big case. Like it wasn't paperwork that people had to read through an index anymore. All of a sudden you could search the documents. And that was a huge change, of course, in discovery. And the second part that had been basically prophesied since the 40s was a way to digitally analyze contracts. And that proved surprisingly hard to find. But now, when you use Lexon, you basically have an abstract syntax tree within the computer that expresses exactly the meaning of the contract. You couldn't have a more perfect way to analyze what the contract actually means and then work with it. What this affects is a speed up in law that a lot of people probably find unthinkable at this point. But it really can collapse these two spheres. It really can, in a certain way, make these two worlds one. And that's very hard to think. I mean, it's the same way like people had a really hard way to think about how online retail would look like 20 to 30 years ago. Like this web stuff, this internet, what would it change, right? And Sears went away because they couldn't adapt, they couldn't change. And I would say it's the same like banking has been changed by online banking, the same like music, streaming. And this is coming to the legal profession, but it's the same like with the legal profession, with the other industries. It's really difficult for them to see it coming. In a certain way, it's just a matter of speed because the speed up is so high that this affects a qualitative change. But also, if you think about it, how law works today and how legal practice works today, of course, there's a lot to be done. Of course, access to justice for people who are not earning a lot of money is a difficult thing to get today. So in that sense, there is an industry that is ready for a change, that is ready for a revolution, and can completely not imagine that 2,000 years of practice, basically pretty much in a certain way, all of a sudden could turn out completely different. So there's a lot of inertia. It will take some time, but the difference that this will make will be very much to the better. It will very much make our world a better place. It will create a completely different way of access to justice. And for this, I think it's worth the wait. Another thing is that we can also bring our testing tools then to contracts, right? Obviously, for programmers, we have a completely different rigor about testing stuff out, because if only a semicolon is wrong, then yeah, we're used to tools that don't even compile the whole stuff, right? And that's very different than the attitude that is in the legal profession at this point. Of course, everybody knows every comment must be right, but the tools that can be brought there, and also with quick checks, with random tests, bringing that to contracting, that's of course going to be a big change. We also need robotic laws, right? We will soon have killer robots that will be a very normal view, probably. And we will have to empower our democratic institutions to be able to make laws, and we'll have to have a guarantee that these programs that are being required are actually really built into these devices. And Lexon is probably the language that you can articulate Asimov's robotic laws with, because that's very much what the accessibility of a programming language gives you. You can put it not only in front of judges, but you can also put it in front of lawmakers. But also, if you just look at the economics of contracts, it's said that 9.2% of revenue is lost just from bad contracting. Having suffered from bad contracts myself, I can totally believe this. It's even a modest estimate, I think. But there's a huge margin that better contracting, more reliable contracting, taking the rigidity of smart contracts where it's good to normal contracts can make a huge difference and can unleash a lot of productivity. So the blockchain, the changes that blockchain can bring, made accessible with Lexon, made and empowering people really to also write their own smart contracts, even if they're not programmers. That is something where a lot of industries can be affected, right? And they basically are in two columns. On the one hand, it's a lot of stuff that has to do with anything financial, including retail, insurances, for example. Why shouldn't you be able to insure your wedding party, right? Well, it's just because it's a complicated business. It's really difficult even for farmers to insure against the weather. But why shouldn't you, with the right tools, be able to create a market for that, right? And we have these tools now. On the other hand, there's a lot about governance. There's a lot about all the now pretty calcified elements where our democracies don't really work very well anymore. And if you can take out a lot of possibilities for corruption or self-serving behavior through blockchain, make it accessible through Lexon, then I think we can hopefully find how we can improve our democratic institutions. Especially for DeFi, though, I think everybody agrees that we will see a crackdown because what happened had just too much scam and bad players in it. But Lexon can be a huge tool to make transparent what the individual DeFi contracts, the smart contracts that drive DeFi, what they actually mean. Also for regulators, also for lawmakers, but most importantly for consumers, users of it. This can be a huge argument to avoid the worst, the shutdown of the entire DeFi environment, basically. I have talked about artificial intelligence before. What has always been my curiosity is in what happens when smart contracts start to communicate with each other in a meaningful way. And I think when I first heard about Ethereum, this was very much what I thought would be the most interesting thing to watch. It didn't really happen the way that I hoped it would. It's starting out. It's a laborious process. It basically goes through standardization of interfaces, the exact same way that the DEX needs the IX9 standard to work, right? And that's true for all interaction between smart contracts. But the other point of it is really accessibility of those smart contracts and being able to understand in a way that is less confusing than code and is less tricky than code what a smart contract actually does. And also in this sense, I think Lexon can help making smart contracts real artificial intelligence agents. Now I would like to talk a little bit about the tech for the time we still have. And I would like to just talk about one element, and that is how the Lexon grammar is being articulated. That's getting a little bit technical now for those who are technical here in the room. You will see that this is very close to BNF, Bacchus Now form. That is a standard way, or has been the traditional standard way of shaking your head. It has the traditional standard way of writing basically the syntax of a programming language. This is a little bit extended. Also, nowadays it has gone into expression parsing, so everybody knows now how a third generation programming language is supposed to work, and so optimization has started, where BNF is not used so much anymore, or not exclusively anymore, and now what we have is optimized ways to articulate a the grammar of a language to make the compilers as fast as humanly possible, as fast computationally possible, to parse millions of lines of code as fast as possible. Interestingly, to create Lexon, it was helpful to go back and use BNF again and extend it just a very little bit by these square brackets, which we all know from how options are being defined in the terminal. And the square bracket basically just means this part is optional. And this is a great example for one step towards natural language from the machines, so to say, because for a normal programming language, you don't need that very often. You try to have a very clear syntax, and you try to not create many ways to say the same things. But in natural language, you do have this. And Lexon, of course, tries to give you a little bit, or as much as possible, liberty in how you phrase something. And it turned out that creating a compiler, basically a pre-compiler, that can use this type of form and then translate it to BNF. And this can mushroom fast, right? You can nest these angled brackets. You can have a lot of them in the same sentence, and you see the highlighted one, action. That's basically the core of it. That's a sentence. That's a definition of a sentence, right? It starts with the subject, and then you can see that it has a predicate in the end, and then has a separator, which could be a colon or a point or a dot. And that's the core, really, of the definition of how the grammar is parsed. What happens in between permissions, or a comma in between, or a condition, and comma, and that's all being, you can leave the comma away or not. It doesn't matter for Lexon. And to have a way to be able even to articulate in a concise way what the grammar should be, these angled brackets made all the difference, because just this action sentence you can calculate through. That's, I don't know, it's probably it's tens of different ways that you can have these optional parts in there or not, and that is being blown up to BNF basically underneath, so that you have a compiler that works completely like it always did, just it has this device on top that I call Lexon grammar form, that allows it to give humans the freedom to articulate the same things in different ways. And this is very much necessary, because we have a different challenge with Lexon. Normally, if you have a normal programming language, this is C up there, it has different function names, but it always has the same form. It always is very strict in how you articulate the head of a function. And with Lexon, we try to capture something else. We capture the richness of grammar, which allows you to say the same thing in different ways. And this is why this is a very modest example, so to say, of how things, using the same tools, using the same compiler tools, have to be done differently with Lexon. Now, I would like to close on looking forward and looking at the stuff that we want to do, and that's the hub. Basically, we'll come online hopefully this year with a tool where all of what I've just explained and can go out the window. You can just try all the stuff yourself, and you can hopefully within minutes publish your own smart contracts on Æternity or offline or on other blockchains. Look out for an announcement that will happen, and I think we will also be able to have a very modest, very simple business model where everybody understands that this can really use blockchain and point to the future of open source, where monetization of open source, especially for small projects, especially also for non-blockchain projects, can traditionally be a very hard problem. And the hub, we're going to use blockchain in a way, together with digital signatures, that is going to make it easy, much easier, to also earn a living being an open source programmer and delivering stuff that maybe doesn't have a huge audience or doesn't have a very specific, high enumerated return on it, but somebody does because they believe that making a contribution that's worth it, and allowing people in a more controlled way to also pay for it. So with this, I would like to thank you very much for your attention.